Hi, in this video, we're going to take a look at how to generate the rigid floors using the groups and the center of mass nodes that we had created. Okay, so this is our model. I'm going to exit out of GT menu now and go to the shell mode. Okay, in the shell mode, if you go to modeling, there is a command called create joint constraints. Here you click on this option called solids, okay, and you can just select the master node point. Okay, so here in the master node point, you want to go to list option. You can also do it graphically, but we have chosen to associate these groups of joints with the master node. Okay, now sometimes it picks the command. Okay, so I made that mistake. So always clear that window. Okay, and then click on the master node point. Click on OK. Now you see the master node point in that box. Let's do that for the slave nodes. Okay, so we're going to go to FL1. Okay, so joint 1001 is associated with floor 1. Now we got to just repeat that, but okay, we need to also give the floor rigid floor name. Okay, so FL1, we'll just pick the same name, and then that information stays the same. We'll click on OK, and in the shell environment, you see the commands related to it. Now, there's two ways. You can actually use this dialog box to create the rest of the floors, rigid floors, or you can just copy those commands and paste it in the command mode, or you can paste it in the file that we had created. Okay, so two ways of doing it. So I'm just going to go in and do this in this dialog box because it's much easier to do it here. So all we need to do is just increment the floor numbers going from FL1 to FL5, okay, in this case. So very easy, as you can see. But again, if you make a mistake, there's a delete option available in this dialog box, okay? So now let's exit out of this dialog box and go to GT menu by just clicking on this icon. And here, you can actually display the rigid links, okay? So if I go to display and rigid bodies, I can just go to check these boxes here and click on maybe one of these floor definitions, and you can see now where that center of mass is located and to which objects is that center of mass associated with. So for each floor, you have that display available, okay? Now, where this really helps you out is the seismic analysis, okay? So when you start applying loads, seismic loads, you do not want them to be, you do not want a flexible diaphragm. So this allows us to create a rigid diaphragm, okay? Action. So here is the 3D geometry. We have assigned supports, we have assigned properties. All we need is to create the seismic loads, okay? Now again, I've zoomed in the screen so it's visible and you can read the information. So we'll just go in, and there's a lot of inputs, as you can see, but I'm just going to go through it very fast, okay? I'm just going to go to each of these node points as, nodes where my floors are located. These do not have to be the center of mass node points, okay? It is just telling GT STRUDL where the floors are located. We're going to pick load number 1 as our load case that contains all the gravity loads, okay, which are going to be used to create the seismic loads, okay? We'll just give some load names, some parameters. We'll just pick maybe a good seismic zone, and we'll just say 12 seconds. We're just going to say S1 and SS is 1. This is just an example, okay, nothing real. And that's the problem here. I've zoomed in so much that you are unable to see the bottom of this dialog box, okay? There is a scroll bar, but let me just see if I can go in and adjust the screen for you so you can see the bottom of this dialog box. You know what? I can probably move this dialog box, or what I could do is highlight or hide this taskbar. You know what, if it doesn't work, we will probably move this taskbar to the right hand side, okay? So Here you see that scroll bar. You can actually move it down. I'm just going to scroll it down. Here we go. Okay, and these are the last inputs here. I'm just not going to change that. Now, if you click on OK, it'll actually create the seismic load generation commands for you based on your inputs that you give. And to visualize those loads, you can just click on this load icon, display load arrows. Here are your seismic loads. Okay, let's run a quick analysis on this, a linear static analysis. Click on done. Here, if you go to results, deform shapes, here you see the rigid action, okay? So the building is actually behaving in a rigid way because you have rigid floors modeled using rigid bodies, okay? And you can see those center of mass nodes here. Thank you for watching. Bye-bye.